We are starting Algebra 2. This is our mission critical concepts in Unit 7 that we want to make sure that we hit before we take our EOC, as well as heading into review day number 2, which will cover the next 7 problems on our mock EOC. I think the janitor might come in here and clean, so if you hear somebody come in or there's a weird break in this video, it's because somebody came in my room with a mop or something. Okay, so let's get into our mission critical activity here. So this is an intro exploration, and I'm just gonna have you guys pause the video if you're doing this from home and work this out. So in Desmos, graph each of the functions shown below and match it with the vertical asymptotes. There may be more than one vertical asymptote per function. And so pretty much what you need to do is, if you didn't watch the last video or you weren't in class for the last lesson, we covered what an asymptote was. It's that line that the graph approaches but never reaches. And we had our illustration, the escape from Algebra 2, and I had volunteers in every class. Nobody escaped. We're all stuck in it together. Now, with the vertical asymptote, you're looking for the line going this way. Okay, so the vertical asymptote, which will have the equation x equals some number. So take a minute and pause the video, and in Desmos, actually make yourself do this. We want to develop fluency and proficiency with Desmos. Just hearing about it or watching me do it is not going to develop the speed and the efficiency that we need for our EOC. So you type in f of x, or you could use a y equals 1 over x plus 3, and then see where the vertical asymptote is, and then match that up with the asymptote that you see there. And then as an extension question, which one has an oblique asymptote? Now you might not know what that is, so we have a clarification. That is, which one has an asymptote that is slanted? So it's not either straight up and down or straight back and forth. It's straight diagonally. Okay, so pause the video and then work that out, and what you're looking for is that pattern. Okay, so I'll stop talking so that you have a chance to pause the video. Okay, so hopefully you have paused the video and you've arrived at an answer. And again, I can't emphasize this enough. It is important for you to be the one doing this. So if you're just like, I'm going to put this video on play and sit here, and then Ms. Taylor's going to give me the answers and that'll be good enough. Maybe, maybe not. All right, but I promise you it's not going to be as good as if you did this and you saw for yourself on all of these graphs how that function is related to the graph. Nothing I say is going to take the place of you being the one to do that. All right, so if you didn't, do it now before I go on to the next slide. So what we want to do after we explore something like that is we want to be able to draw some conclusions. So the next piece of this in class I'm not going to stop and give students the answers either. So what I would do in class is I'm going to go around and make sure everyone's doing it, and then if somebody's having difficulty with it, so they don't know how to get something in the denominator, or they don't know how to match it up, or they get thrown off, I'll provide some guidance there. But I'm not going to go over all of them in class. So I'm not doing it for you either. Now, without graphing, where do you think these functions will have vertical asymptotes? So now that you've had a chance to explore and look and see if you can find some patterns, we want to make a prediction based off of the patterns that we've observed and see where will these functions have vertical asymptotes. So pause the video and make a quick prediction in your notes somewhere. I'm going to have an announcement.
Pardon this interruption. I need the following student to report to the main office at this time. Thank you.
Okay. So make your predictions, and then we will check those by graphing. And this is going to change my view when I click on it. Maybe, maybe not. It's not doing anything. Wait. There we go. Okay. This is very weird. All right. It has not ever done this before. Every time I do this, it changes my view, which I don't think you guys can see, but it changes my view on my side, and it did not do it this time. So it's very weird. Okay. So we're going to type in y equals, and I'm using y equals because it's more efficient. It's faster than f of x. You can use either or. X over x minus 2. Okay, and what hopefully you can see is that that moved the graph to the right, and probably to the right 2 units, since you know that subtracting a 2 inside of any function will slide it to the right 2. But I'm going to go check that with x equals 2. And as I learned the other day, if you long click on this, you can change that to a dashed line. Maybe. There we go. Yay. So we can dash that because it's not actually part of our function there. And so you can see when we do that, that the graph does have a vertical asymptote at x equals 2. Now looking at the next one. This is not working the way I would like it to work. It seems like we have a very long delay. It could make for a very long video. Okay, this is -2 over, and then I have x plus 3, x plus 8, and that's a cool graph for sure. Definitely a cool graph. It has more than one asymptote. And so let's come down here, and it looks like we have an asymptote at x equals -3. And I don't think it's going to let me do that. Nope, it's going to error. I was just wondering if it would let me do that, but the answer is no. And x equals -8. And let's see if I can make that one dashed as well. I could also change the color on that so that my asymptotes were all the same color. There we go. So we're going to make all our asymptotes the same color. Okay, and so there are 2 vertical asymptotes there at x equals -3 and x equals -8. And then the question here, and this is for you to think about, were you correct? In other words, did you see the pattern in that first set of exercises that was accurate enough that it carried over? Now, this is low risk. This is a in-class exploration activity. So if you see the wrong pattern or you flip signs around, there's literally nothing bad that can happen. If that happens, you just want to make a note about it and make those corrections, and then we move on. So the whole point of that first piece there was to get you to see, first of all, see a lot of rational graphs, like see what they look like, and to continue handling and looking at these vertical asymptotes, and then to start to see that there's a pattern. The vertical asymptotes don't just appear wherever. We hopefully makes sense that math is consistent in our equations, and what we're looking at on the graphs are connected, and so you can make predictions about the location of these asymptotes or features about the graph when you are looking at the equation itself. So the key idea here is vertical asymptotes can exist where the denominator of the function is equal to 0. Now, dividing by 0 is an undefined operation. If you put into your calculator 2 divided by 0, it will error on you. Okay, it's going to error. That says A-H-H. All right, it's not defined. So if you have something like this, if you have y equals 2 over x minus 4, if x is equal to 4, then what's going to happen is in your denominator, you're going to end up with 4 minus 4, and you're going to get this 2 divided by 0, and that's undefined. So what that means in terms of the graph is that there's no graph at that spot. Okay, it means that there's literally nothing there, and that's what gives you that discontinuity or that break in the graph. You have to jump from one part of the graph to another. So anywhere you have the denominator equal to 0, the graph cannot exist there. Now you'll notice that this is probably making you a bit uncomfortable if you're paying attention. The vertical asymptotes can exist. Doesn't mean they have to. And so there is one other thing that might happen. Sometimes there will be a hole in the graph instead. And we'll look at that in a future lesson. So when the denominator is equal to 0, a lot of times you're going to see this asymptote, which is what hopefully you noticed in the exercises. But sometimes there'll be like this little break in the graph, and it's just this hole, and you actually can't see the hole, because if you think about the fact that a point is infinitely small, it doesn't have any dimensions to it, and so you could take a point out and you would never see it because it's too small to see, but it's happening. It's one of those situations where math can really mess with your head a little bit, but regardless, if the denominator ends up equal to 0, you can't have a graph there, and so that's the candidate there is for the asymptote. I would even say most of the time you're going to have an asymptote. But once in a while, this other thing can happen. So I just have to be careful that I'm not saying all the time you'll have an asymptote there, because there is this other thing that can happen, but it doesn't happen all the time. All right, and that was it. Okay, so the main point of that little mini lesson, it took me 13 minutes, not including what you would have to pause to do it. So in class, maybe we'd be looking at I don't know, 30 minutes or so for the class to be able to do that and to know, okay, where am I going to see those vertical asymptotes? So as we go into the review work for the EOC, be sure to work each problem on your own before we go over it. Okay, and same with the video is no different. Pause the video and make yourself analyze, look through, explore solutions on your own, and then use your packet to take notes as we review about additional methods or ideas for navigating the exam. So don't just settle for, okay, I got the right answer. We want to look at different ways to get the right answer, or the best way to get the right answer, or maybe you got the right answer, but it was just sheer luck that you got the right answer. So use the packet for some notes. Okay, so I had to re-record on this slide because I clicked off onto the next slide before I was done with this problem. I think I hit the scroll wheel on my mouse, and so there was a lot of instruction that went into the development of this that I have lost. So I'm sitting here wondering, to what extent do I want to go over it? So we have the table here, and we have the population of the city, and it says using an exponential model estimate the population in 2016. So what I did was I clicked here. So I am going to go through this to at least some extent. This little plus sign, and clicked add table, and then inputted the table that you see over here into Desmos, and it gave me these points. Now you might notice that I have some extra lines here, because the first thing I tried to do was, instead of doing the regression, I tried to just type in my candidate other points. And so I tried typing in, oh my gosh, I'm fighting with Desmos. Okay, we'll type over here. So I tried typing in the 2016 and then the 594164 to see if that looked like a good candidate. And you can tell from where the point is on the curve that it looks like, it looks like it's on the curve. And then I did the others. And so I tried 2016 and then I did 603934. And now you can see kind of what the problem is that both of those points look like they're pretty good points. And so I tried out all the answer choices and there was nothing I was able to eliminate. It all looked like, they could be on there. Now that I have a curve on there, I think maybe we could go a little bit further with that. But without the curve on there, it's like they all looked reasonable. So what we had to do was I went in and I deleted those points because I didn't want them to throw off any kind of curve that Desmos could give me. So I'm going to go back in and delete them. And then we did a regression. So remember, when you're doing a regression, you need to use the X1 and the Y1 instead of just XY. And you also need to use the little tilde. And the piece of information that you probably need to write down is this, that your general form is going to be A times B to the X. Now, there are some like shifts that you could do with that, but I don't think they're necessary here, and we don't want to overcomplicate it if we don't have to. Now, it is giving me a value there for A and saying that A is 2.47 times 10 to the negative 62, and B is equal to 1 point. I still do not like this problem. So now, so like I said in my first recording, I said what you're getting is what would Miss Taylor do if she were working on this particular problem. And my gut, if I were taking your EOC and I came across this problem at this point, is I would start this problem and I would move on. I'm not out of ideas, and I think I can still figure some stuff out with this, but I don't like how it's going. And I think it's going to take me longer to figure out than I would want to spend during tests. So if you're wondering, when would Miss Taylor leave a problem alone? This is it. This is when I would leave the problem alone. But this video will not let me back up on my problems. So what I'm going to do, in the interest of preserving your time, and 5 minutes is long enough for you to spend on one slide of this, I'm going to pause my recording, and I'm not going to skip it. I'm going to pause the recording and work it out, and then meet you back here for you instantaneously. Okay, so I have to quit. Not because I don't have any ideas to do this math problem, but because I cannot get this table to cooperate. It like keeps deleting numbers, and I had to delete everything, and the cursor is sticking everywhere, and it's not modeling what I wanted to model. So I can spend the next hour here staring at this particular problem, and or I can move on and hope that the next couple problems are better. And then what I will do is I will record a separate video screencast of this particular problem so that I can at least make some headway. But that was not going to work. I don't understand what it's doing. Normally, once I click over into Desmos inside PowerPoint, it changes my view, and it's not changing my view. And it's malfunctioning. So I don't really know how the rest of this video is going to go, but we're going to try to see what we can do. I'm going to move on to the next slide, and then just be alert for directions, because obviously you're missing this problem. So, okay. So let's hope that this goes better on this slide. If it doesn't go any better, I don't know what I'm going to do, because I cannot keep fighting with I just can't keep fighting. Yeah, and like I'm still fighting with it. So all right. So problem 9. Mia invested $5,000 in an account that earns 4% interest compounded continuously. To the nearest tenth of a year, how long will it take her to double, for her investment to double? So this is one that actually you can't put the whole thing into Desmos, and you're not even going to graph anything. We're going to use it as a calculator on this one. So first thing we want to note is that it's compounded continuously. So on your reference sheet, you're going to go grab that formula for continuously compounded interest. The formula is on your reference sheet, but you need to know what it's for. So when you read compounded continuously, this is the formula you need. Now, she is investing $5,000. So remember what I said earlier, we want to kind of create our list of numbers that we know. So the principal, which is the amount invested, which is why definitions and vocabulary are important, because otherwise you don't know where that goes. The interest rate is 4%, but remember that has to be as a decimal, so 0.04. And we want to know how long it's going to take her investment to double, which means the final amount would have to be 10,000. Now remember that you don't actually need to have either of those numbers. You could just say, how long does it take for it to double? Okay. And then we plug each of those in where they go. So 10,000 is equal to 5,000 e to the 0.04 t. Again, we were asked the nearest tenth of a year, how long? And now we need to solve this for t. First step, and this was a bad spot on your test. This should be 10,000, missing a zero there. Is isolating the exponential. You have to isolate the exponential first. 10,000 divided by 5,000 is 2. And then we're going to change the form over. The number of you that took common logs or natural logs of both sides. I never showed you how to do that. That is not something you ever saw from me. So either you diligently studied something other than your class notes and videos and went outside of class and found a totally different way to do it that wasn't what was ever presented or practiced or modeled for you, or you were accessing something else during your test. I don't know which one applies to you being generic students out there. I taught you how to change the form, partly because that formula is also on your reference sheet. So this would be log base e of 2 is equal to 0.04 t. Log base e is just natural log of 2. I saw a lot of i's on your reference sheet. And then we would divide both sides by the 0.04 to get, space, t equals something. And this is why we need Desmos up, because we're going to use Desmos to do the evaluation of that. So I need to take the natural log of 2, is 0.693. And then we will take that 693,147-ish and divide that by 2. And, oh, no, not by 2, by 0.04. And I get about 17.328, which fortunately, yay, matches one of my answer choices. So this is one where, like, Desmos is just not going to do this problem for you. So you're going to need to bust out your scratch paper. You need to know what formula on that reference sheet you're going to be looking at. You're going to need to know how to solve the equation, but then you are going to need to use the calculator feature of Desmos to evaluate it, because there's no way that we have to do that on our own. So that brings us to answer choice C. Okay, it's gonna be a miracle if I get through this. This is not working right. Number 10. Carlos deposited $1,200 in a bank account that yields 8.5% interest compounded annually. That means it is compounded once a year. How much more money would Carlos have after 20 years if the interest was compounded monthly? This is an awful problem. I don't think I would do this right off the bat. This is another one that to me kind of says, this, I mean, I can do it. Like, we've got our formulas on our reference sheet to do it out, but I can tell it's going to, it's just got a lot of parts to it. But let's see what we can do with it, okay? Because that's how we're rolling. So I'm going to open up my calculator here. And again, the calculator, this is mostly just to use a calculator. Most of this is going to be our scratch work. And I have a feeling we're going to have quite a bit of it. So this is compounded annually. Notice it doesn't say, or compounded monthly. It doesn't say compounded continuously. So that's your tip off that you're going to use the other formula, which is the A equals P, and 1 plus R over N, all to the N times T. I think that's it. Okay, now the issue here is that we have a ton of stuff going on. So we have the amount that Carlos is investing, which is the $1,200. Okay. And then it says the interest rate is is 8.5%, which as the decimal is going to be 0.085. So you're going to, now if you don't remember how to do that, remember percent means out of 100. So you do 8.5 divided by 100. Okay, because that's literally what percent means. Now, here's the pieces that change. The first situation, it is compounded annually. So that would be once a year, and the time period would be 20 years. And so you would have basically 20 compounding periods, okay? And so we're going to dump all of that in, and we're going to find out how much money Carlos has. So we've got $1,200. 1 plus 0.085 over 1, and then this will be 1 times 20. This is why we have Desmos open, because we are not messing with that. Okay, so $1,200, 1 plus 0.085 over 1, kick that out. And then I'm going to do 1 times 20 in my head to get 20. And in that situation, Carlos has $6,134 and about 46 cents. Now I need to save that money, that number somewhere, because that is not the answer to the problem. So that is $6,134.46. We're going to round that up to the nearest penny. Now, the question was, how much more money would he have after the 20 years if it were compounded monthly? That is going to change the N value to 12. Okay, so that's just like a little bar there. That changes the N value to 12. It means it's compounded 12 times per year. So in this version of the problem, we have 1,200, 1 plus 0.085 over 12 to the 12 times 20. And once again, we are not messing with this, okay? We are dumping it over here. And remember what I've said in class about efficiency? Don't retype all of that if you don't need to. which, knowing how this is working for me today, I need to. I'm just not, like, it's just not, it's not happy with me. Okay, 1 plus 0.085 over 12. Okay, and then in my exponent, I want 12 times, I knew that was going to happen. You have to put parentheses around it. Okay, and that is $6,529. We're going to write this. Of course, we're not going to write it. Of course, it's going to delete this on me. I can't. Okay, I'm just going to write it here. 2.49 cents. Okay, so one of those numbers is if it is compounded just once a year. So there are 20 compounding periods. The other would be compounded 12 times. Yeah, so a lot more compounding periods. Now, the question is, how much more money does he have in the second situation? So our last problem here needs to be a subtraction problem. So 6529.49 minus 6134.04, and I have $395.45. That one has $395.04. Because I typed that wrong. That should be 46. There we go. Now, you might be wondering, okay, Miss Taylor, why is that different? Why do you have 3 cents and the answer choice has 4 cents? Probably that has to do with where in the problem I rounded stuff off versus like other directions for rounding. So like I rounded the original one up to 46 cents because the next digit over was a 5. But if somebody were doing that in like smaller pieces on a handheld calculator, they might have rounded off in the middle of the problem. And so theirs actually would have rounded differently. If that happens to you, you don't sweat it, okay? Because there are no directions in this problem specifically about rounding. Now, this is a big problem. Okay, so realistically, there's a lot of stuff happening in this problem that that might prompt you to say, I don't want to do this problem right now. You know it's a formula. You know you can dump the formula into Desmos. It's still a long problem with a lot of pieces to it. And the next problem might be easier. And you don't want to stress yourself out or bog yourself down. Kind of like with that problem earlier, Desmos was giving me a hard time. It wasn't working. Okay, it's not working. I'm going to try to make sure that I can get a recording of that for you. But there comes a point where I have to say, I got to move on to the next thing because the next thing might go better. And in this case, we've done 2 other problems. All right, let's move on to the next one. It just stopped my recording. It just stopped my recording. You know when your technology really gets messed up and you get really frustrated? That happening right now. It's bad, 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 bad. Okay, so now I got to back up and do this over again. And anyway, we have an equation here. Now, so annoyed that I have to do this over again. If you have a 4th degree polynomial equation, it means there are 4 solutions to it. Okay, so 4. Now, they could all be real. They could be some combination of real and imaginary. They could all be imaginary. If you have imaginary solutions, then they need to come in pairs. So looking at my answer choices here, I have plus or minus. That means you got 2. Okay, one that's positive and one that's negative. And all of my answer choices that have an I in them are all plus or minus. So if you saw something that had like just one answer that was imaginary, that you don't pick that because they always come in pairs. So if I graph this, which you can tell that I have because I did this problem earlier and it kicked me out, but yeah, it will show me the real solutions. So what I was hoping for when I graphed it, and I originally graphed it with the 0. The 0 doesn't allow you to pick, like kind of hover over the answer choices there. Yeah, so I graphed it. What I was hoping was that it was going to be plus or minus 3, because then I could clearly see that it was plus or minus 3. And yeah, I could see that it was plus or minus 3, and I wouldn't have to do the rest of it. If I could see the real solutions were plus or minus 3, I have my answer. But they're not. Okay, which means now I have to tangle with these. Now, what I'm hoping for is that it's going to be equal to the square root of 6, because then I can get that answer. If it's the 2 root 2, then I have to go back and tangle with that imaginary part. And what I'm trying to do is I'm trying to avoid that. So in Desmos, I'm going to type in the square root of 6 you haven't lost your sound. I'm just mad. You guys are watching what's happening, right? See where the cursor is? We all agree where the cursor is? I can't. I just can't. I'm going to absolutely lose my patience with absolutely everything. Because I can't. This is kind of what it was doing with the table when okay. 6. Okay. So when this happens, we're going to go to something else. We're just going to go to a hand calculator, because I have to finish this video and you guys have to have this resource, and I am going to lose it. So the square root of 6 is 2 point. I'm just going to type the number in. Or you know what? Why should I bother typing a number in? Why would we want a number in? Why? Now it's just turning the pen feature on. It's keep slides updated, end show. I would love to end this show. This is a terrible show. Okay, 2. Okay, I can't. I'm gonna write it in because I'm gonna go crazy. The square root of 6 is equal to 2.449, and that's probably enough. Then I'm going to do 2 root 2. You should be able to just do this on Desmos, like, a normal day. So 2 times 2, and that is equal to 2.8284. Now I need the Desmos to work. I need to come back up here, and I need to see where these points are. Thank heavens. Okay, see where that is and where that is. Okay, that's really, 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 really good news. Oh, I needed really good news, because I've been on this slide for 6 minutes, and that is ridiculous because I'm fighting with this program. So what that is it's telling me that the real answers to this are plus and minus root 6. If I know that they are plus or minus root 6 for my real answers, then it has to be this. if it had come out that they were the plus or minus root 2, then I would have to tangle with the equation. And what I would probably do is I would probably pick either the I root 6 or the I root 3, and I would plug them into the equation to see if they were true. Okay, so I would like take I root 6, raise it to the 4th power. That did not happen, and on a better day, I would demonstrate for you how that worked, but this is not that day. So I'm not tempting fate. We are going to go on to the next slide and see if we can knock this out. All right, this one does not need Desmos. Thank heavens it doesn't need it. So question 12, which characteristics describe the function shown on the graph below? And so we want to notice a couple of things, and this is a great review of your end behavior. When you have an odd degree polynomial, then the ends point in different directions. So you can think odd is like a line, because a line is degree 1. Okay, and your ends are going to point in opposite directions. So you might have the one side pointing down, the other side pointing up, or it could be the other way around, depending on the leading coefficient. So if its leading coefficient is positive, it's got like a positive slope. Negative would have a negative slope. Now, if it is even, it is like a parabola. Okay, and the positive would have it like happy face, like positive person, and the negative would have it as a sad face. Okay, there's like your, I'm reviewing for my EOC, like, oh, that's right, we studied that a million years ago. So the degree of f of x is odd, and we got the leading coefficients down here. So answer choice A. So now we just have to go through the answer choice and see what we got going on. Now we got a bunch of zeros here. And guys, so we have zeros in all these places, and they're going to ask us some questions about that one. That means, and I think we did it in class, that the multiplicity was 2. It just means it's even, but usually it's 2. It's like it counts going up and then counts again coming down. Okay, so the degree is odd and the multiplicity of the 0 at A is odd. That is not correct, because it is not odd. Okay, this would have even multiplicity. That's what causes it to bounce off the x-axis. Now, it is an odd degree polynomial because one side is going up and the other side is going down, so it fits this scenario right there. Second one, the degree is odd and the multiplicity of A is even. I like that answer choice. Now, if I've got the time, I'm going to read the other ones and just make sure. So the leading coefficient is positive. That would be true. That's that situation right there. But then we have this going on again where the A is odd. The multiplicity of the A is odd, so that's not right. And then the leading coefficient is negative. Nope, that would have it going the other direction. So I'm super happy with answer choice B. Also really happy to have a problem that I didn't have to fight with Desmos. Don't know. It was working fine today in class. The day that I'm recording this, it was totally fine in class today. It's something about running it inside the PowerPoint that is just being horrible. So it kicked me out of the problem again. I have been recording this. I've been working on this video for an hour or more, and it's only a 44-minute video, which gives you an idea of how much time I've had to re-record stuff and pause it. And it kicked me out again. And then it made my face really tiny, like really tiny, and I don't know. So I just want to get this done. Just want to get this video done. It's the worst video ever. And my computer is saying that I've got the circle of death. So that probably means this isn't recording sound or something. I don't know. That would be it. So we have to solve this quadratic. And so we're going to try to solve it by graphing. We can tell when we're looking at the answer choices that this is a quadratic formula caliber question because of the square roots. The square root is going to come out of the quadratic formula. You're not going to get a square root when you're factoring. And so I don't like the quadratic formula. I'd like to avoid it. So what I did was I graphed it. And if you could have seen, you know, the stuff that I already recorded that I can't keep, I had gone over this, and the good news is now I can't zoom out. I tried to zoom out. It did not let me zoom out to see the other root because of course it didn't zoom out to let me see the other root. But we have the root right there. And what I did was I wrote that down. So we know that x equals negative 1.0710 is one of the answers. And that's super good news because what that means is that this is not imaginary. So it's not A or B because I'm able to see one of the roots. Now I'd like to be able to see both of the roots, but I mean, of course not. Now you should be able to see them. Now what I'm going to do to determine the answer is I'm going to enter in my answer choices over here until I find the negative 1.071. In some kind of world where things worked appropriately, I would be able to type that into Desmos where the blinking cursor is, but when I hit the buttons on my calculator on Desmos, nothing is coming up on the screen. So I'm having a blast with that. I'm going to convert over to a different calculator and type them in on a different calculator, and just you guys at home, or this is gonna, you guys don't have to watch this the day I'm out. I'm so sorry. But yeah, you're gonna have to type it into Desmos. It should work just fine. Okay, so I'm going to start by typing in negative 6 plus 5 square root 2. And I get negative, I get positive 1.071, not the negative, I'm getting positive. So what I did right there, and if you're wondering because you can't see what I'm doing, is I just typed into my calculator negative 6 plus that. And that gave me positive 1 point something, which would be right here on that. So I'm reasonably sure it's not that answer choice. Just for fun, I'm going to plug in the other version of that, negative 6 minus 5 root 2. And that gives me negative 13 something. So I don't like answer choice C. So looking at answer choice D, I'm going to plug in 6 plus 5 root 2. That gives me 13 something. Now that could be an answer choice. I can't tell. My graph is stopping at 10 and I can't zoom out. You guys should be able to zoom out. Zoom out, properly functioning, everything. So let's look at that last one. 6 minus 5 root 2. And there's the number I'm looking for. So what I did was I just plugged these into my calculator. Negative 6 plus 5 root 2, negative 6 minus 5 root 2, 6 plus 5 root 2, 6 minus 5 root 2. And I was looking for this number, which is the number that I can see. And so I was able to find it. And so the one that has it, which is answer choice D, is my answer choice on this one. Okay, we have one more problem. I am doing this. This problem, you'll notice there is no Desmos on the screen. This one Desmos cannot help you out with. And part of the reason we're reviewing all this is to establish what kinds of things Desmos will do for you and which kinds of things it won't. And this is one that we just have to work out. Unless you own a graphing calculator. If you own a graphing calculator, it has the ability to compute with imaginary numbers. We just have to set the right mode, and you need to know where to find the key, and you could just dump this in and get your answer. For everybody else, we just have to go through it. So let's take a look at that first part. We're going to take a look at the 7 minus 2i all squared. Okay. Remember that when you square something, exponents can't be distributed. Okay, that would violate your order of operations. You can't square the 7 and the 2i before you subtract them, because the 7 minus 2i is in parentheses. So you have to handle that first before you can square them, okay? Now, the way we do that is by rewriting that squaring as a multiplication. Okay, now notice I'm working top to bottom. I'm going to copy everything else down. This becomes either a FOIL problem or an area model problem. Okay, so I can come over here and do the area model on that. We'll just be consistent. So we're going to do 7 minus 2i times 7 minus 2i, which is going to give us 49 minus 14i minus another 14i plus 2i squared. But recall, I squared is equal to -1. So this would be 49 minus 28i plus 2 times -1. Now we're going to bring it back over here to this problem. 49 minus 28i. Now 2 times -1 would be -2. And let's go ahead and distribute that, so that's minus 25 plus 12i. Okay. And we have to combine some like terms. So I've got, what do we have going on? We have 49 minus 2 minus 25. Minus 2 minus 25. Oh, I don't think I did that too. Right. 49 minus 2 minus 49 minus 2 minus 25, and I get 22. Well, that's no good. Okay, I don't know what I did there. It's 2 minus 25. Oh, good grief. I can't today. No, I can do it. You probably saw it. This is not a 2. You guys can't see where I'm pointing. That's not a 2. 2 times 2 would give me 4. So I guess, since this is an absolute train wreck of a video, I might as well just point out that that's what you do when something doesn't come out. Now, I think the eyes would have come out okay. But I still might have had to go back and find that mistake. So this right here, let me change the color up. We'll do a blue. This should be a 4, which means that should be a 4, which means this should be a 4 over here. Let me go and erase that. Like, that's the part that is messed up. So this should be a -4. Okay, so 49 minus 4 minus 25 gives me 20. I like that better. That's over there in my answer choices. And then I have -28i plus 12. And that gives me -16i, which, thank heavens, is an answer choice. I don't know. Making a mistake, like 2 times 2 is 4, which obviously I know, and I'm just not having a day of it. This is probably the worst video I have ever recorded in my life, and I'm doing it on a day when I'm going to be absent, so a bunch of you are going to have to watch it. It's not good. But we made it. We made it through the problems. Actually, no, we didn't. We didn't make it through the problems because I had to stop on that table one. So what I am going to do, because I'm determined to see this through, is I'm going to record a separate video with that other problem. So when you have finished watching this and you think you're done, you're not. Just kidding. There'll be another video. I promise to keep it short. Okay. So there you go. Update your mock EOCs, and you might very likely have a bajillion questions on this. So please let me know, not if, but when you have the questions. Okay. And if I could have made this better, I would.